This is video on problems 3 and 4 on the ideal gas law. So the ideal gas law tells you how many moles of gas you have, or at what pressure, at what temperature, or how many grams. You can get a lot of different things out of the ideal gas law. So problems 3 and 4. I'm going to show you a little bit different here. If you want to manipulate the variable before you put numbers into the equation, sometimes that is easier for people. So if we're looking at problem 3, it says at what temperature. Okay, so it's looking for a temperature. Remember, temperature will be in Kelvin. R is 0.0821 every single time. It's a constant. N is your number of moles. V is your volume in liters. Remember, P is your pressure in atmospheres. So it's not in atmospheres. We have to convert it to atmospheres. So if we want to manipulate the variable, we can do that. Okay, we can do that. So number 3 is asking for temperature. So if we want to get temperature by itself, I can divide by N times R on both sides. So those cancel. And I'm left with PV over NR equals T. So you could do every problem like that. If you want to solve this for P, or solve it for V, or solve it for N, if you want to do it that way and then plug numbers in, you can do it that. So I'll show this problem this way. So we need a pressure, volume, moles, and our R value, and set it equal to T. So in the problem it says we have 700 millimeters of mercury. So remember, 700 millimeters is our pressure. So I've got to put that in as 700 divided by 760. And you can figure that out beforehand if you want to, and plug that in. So remember, we're dividing by 760 to get into atmospheres. Here's our pressure. The volume was 5 liters. Those are 5 liters. So pressure, volume, N and R. So put our N in down here. I know my R is going to be 0.0821. And our number of moles. Well, we have 7.5 grams of CO2. So 44 grams is a mole of CO2. So I take 7.5 divided by 44 is 0.170. So 0.17 moles of CO2 will go in there. So all that is equal to T. So now we can just plug numbers in and get an answer. Our temperature is, remember, it'll be in Kelvin, so temperature is about 329 degrees Kelvin. So if we want to get that into Celsius, we could subtract minus 273, and our Celsius would be 56.2 degrees Celsius, or 56 degrees Celsius, somewhere in there. So again, you can manipulate the variable first if you like to do it that way. Problem 4. Problem 4 is the hardest one. Okay, problem 4 is a little bit harder. So problem 4 is asking you to determine the molar mass or the molecular weight. Okay, so that's usually what you get off the periodic table. So for number 4, we're trying to figure out how much would this gas weigh off the periodic table. We can't look it up because number 4 does not tell us what gas it is. So we can't look on the periodic table and see what the molar mass is, but we can figure out molar mass from the equation. So there's your equation. Remember, N is your number of moles. And if you think about how you get moles by taking grams of a substance divided by the molecular weight, or the molar mass. So the molar mass is in this equation, but it's kind of part of it in a weird way. So I'm just going to solve this for N. Okay, we're going to solve for N. So it tells us our pressure is 740. So we can go 740 over 760. That'll get it into atmosphere. So we have a little bit less than an atmosphere because we're at 740 millimeters of mercury. The volume is 2.6 liters. There's our P, there's our V. I'm going to put N in for moles, so we're going to just solve for the number of moles. R, 0.0821. And our temperature, remember, has to be in Kelvin, 15 degrees Celsius, so 273 plus 15. 273 plus 15 would be 288 Kelvin. So if I multiply these two quantities right here, I multiply these two, I get 2.532. If I multiply these two, it's going to be n times those two, and I get 23.64. Obviously, you want to get the variable by itself, so divide both sides by 23.64, divide by 23.64, that cancels, we're going to have n equals 0.107. So remember, that is our number of moles. It is a small one. That's a number of moles. So if you remember, molar mass is grams per mole. Well, it told us in the problem that we had 1.85 grams. So it said that our grams was 1.85. And molar mass is how many grams per mole. So how much does 1 mole weigh? So if I divide it by the number of moles, 0.107 moles, that would tell us how many grams there are per mole. So go back and use the 1.85 grams divided by the number of moles. If we do that, we get 17.3 grams per mole. So that's the molar mass. That might be like a gas like NH3 or something like that, which is 14 plus 3 would be 17. So maybe that's ammonia gas.